In this question, RTD data is given in the form of a graph, so representing x-axis as time and y-axis is x-days distribution of the tracer molecules inside the reactor. So the question is given as the RTD E of t is 0 until 3 minutes. Up to 3 minutes it is 0, and then it is linearly increases to a maximum value of Emax. So this Emax value is not given in the question, after which it linearly decreases back to 0. So it decreases to 0 at time t equal to 15 minutes. Time t equal to 15 minutes. So now here in this question we need to calculate the two parameters. One is what is the maximum value of the x-days distribution and the mean residence time spent by all the molecules inside the reactor. First, see this here, the x-days distribution curve, it is in the form of a triangle. So as we already know, the area under the curve, area under the E curve, it is represented by integral 0 to infinity E of t dt is equal to 1. Okay, so here the area under this x-days distribution, integral 3 to 15 E of t dt, this is equal to 1. So if we find the area under this triangle, that should be equal to 1. So area of the triangle is half into base into height is equal to 1. So here this implies half into, so here the base is 15 minus 3, that is 12 units of time, multiplied by h is Emax. H is Emax, that is height of the triangle. This is equal to 1. Then based on that, Emax is equal to, it is 2 by 12. This is nothing but 1 by 6. 1 by 6 is the value of the Emax. So now we need to calculate mean residence time. So our first question is over. Now the second question, that is calculating mean residence time. So what is the mathematical representation to calculate the mean residence time spent by the molecules inside the reactor is, it is integral 0 to infinity t into E of t dt. This is t bar, mean residence time. T bar is equal to integral 0 to infinity t into E of t dt. So here the integral term is integral, it is 3 to 15 t into E of t dt. E of t dt. So now we need to calculate the mean residence time. So for that, what I am going to do is, I am assuming some values of t. I am assuming the values of t, like I am considering 3, 8, 15. See, whatever the values that we know in the x-axis, those values only I am considering. Correspondingly, I am going to read what are the values for the x-days distribution. So for E of t values at time t equal to 3 minutes is 0, and whereas at time t equal to 8 minutes, E of t value is Emax, that is 0.166, and for 15 minutes it is again E of t is 0. So now I am going to do multiplication t into E of t, t into E of t. So here t into E of t, if I do, this is 0, this is 0, and this 0.166 into 8, that is nothing but 1.33. So now I need to plot a graph. What is the graph here? Graph represented as t as x-axis and y is t into E of t. Since it is an integral term, if I do area under this curve, that will gives you the value of mean residence time. So t into E of t, this is x-axis is x-axis is so e into t of t, that is the first value time t equal to 3 minutes, 3, 8 and 15. So for 3 time is 0, that is in t into e of t is 0, and then next one is 1.33 somewhere here, and here another one. So you will get a triangle something like this. So this maximum value is 1.33. Now area under this triangle, that will gives you area of the triangle is half base into height. This is equal to half into, so base is same, 15 minus 3, that is 12, multiplied by height is 1.33. So this will give you mean residence time, that is 1.33 into 12 divided by 2, that is 8. So 8 minutes. So for this question the mean residence time is 8 minutes. This is the solution for this question.